Now let's take a look at closure. When we look at closure for an operation such as addition, what does that mean? Well, set A will be considered to be closed under that operation, in this case addition, if and only if any two elements of the set, when we do that operation to them, so in this case when we add them, will also be maintained in that set. So what we do know, for example, the set of whole numbers are going to be closed under addition. And why is that? If we let A and B be any two elements of the whole numbers, then that will imply or guarantee that A plus B is also going to be a whole number. So for a specific example, and there are infinitely many examples of this, if you just consider the numbers 2 and 3, which are whole numbers, if we add 2 plus 3, we'll also get a whole number. So we do know that the whole numbers are closed under addition, as well as the integers and real numbers, etc. So we can use the number line model to kind of show this. If we have tick marks here, if I go to the right by a whole number and then I go to the right by another whole number, I go 3 more, I will land on a tick mark, or a ladder step if you will, and I will end up being at a whole number. So instead of 2 and 3, we could call this A, we could call this B, and then this would be A plus B is where we will land, and it will be on a whole number as well. So the set of whole numbers are closed under addition. So let's look at an example that's not closed under addition. And we don't have to restrict ourselves to whole numbers in general, but let's look at a simple set. Let's let set A be the set containing 1 and 2. If I take any two elements here, well, how about let me look at a different one. Let's throw 0 in the mix. Let's look at the set containing 0 and 1. If I look at the set containing 0 and 1, first of all, is 0 is an element of A and 1 is an element of A. Now, the question is 0 plus 1 an element of A? Well, 0 plus 1 is 1, which is an element of A. In fact, we could also take 1 plus 0 is 1, is still an element of A. So we're okay so far for closure. However, we can also use the same element. So 0 plus 0, that's 0, that's also an element of A. So we can add 0 to itself, and I'm still maintaining the set. However, what happens if I take 1 plus 1? Well, that equals 2. So I could take an element of A plus another element of A, but it ends up being an 2, which is not an element of A. So this is a contradiction. So that's a box with an X, means that is going to contradict closure. So what we can say about the set A containing the elements 0 and 1, that this is not closed under addition. We can also look at closure for any other operation as well. So we can look at closure for, say, multiplication. A set is closed under multiplication if and only if A and B are in the set, would imply that A times B is also in that set. Let's look at this set. By the way, we also have closure for multiplication of whole numbers, because what does multiplication mean? It means repeated addition. So since multiplication is nothing more than repeated addition, and we have closure for addition of whole numbers, we will also have closure for multiplication of whole numbers. Let's look at this set. We said it's not closed under addition. What about multiplication? Well, if we look at this, basically we can look at all possible outcomes here. If I take 0 times 1, that's going to equal 0, which is an element of A. If I take 1 times 0, that equals 0, which is still an element of A. If we take 0 times 0, I get 0, which is an element of A. And if I take 1 times 1, I'll get 1, which is an element of A. So I do not have that contradiction, and we can say that the set containing 0 and 1 is closed under multiplication. Okay? So we can also do this for other operations such as division and subtraction. Is this closed under subtraction? The answer would be no, because 0 minus 1 is -1, which is not in the set. It's also not closed under division. 1 divided by 0 is undefined, and that's not an element of the set. So we do have closure under multiplication, but we do not have closure for this set under addition, subtraction, or division.